Okay, we'll do a quick review of quadratic equation on the topic of discriminant and nature of root. So for a quadratic equation, if the discriminant is greater than 0, it means that you have two real and distinct roots. Discriminant equals to 0, you have equal roots, and discriminant smaller than 0, you have no real roots. Okay, the discriminant is found by b, which is the coefficient of x, b squared minus 4a, a is the coefficient of x squared, and c is the constant term. So let's take a look at a question. Find the range of values of k for which the equation, this equation, has two real and distinct roots. So if you need two real and distinct roots, your discriminant needs to be greater than 0. So before you can actually find your discriminant, you first need to rearrange the quadratic equation to equate it to 0. Only when you equate it to 0, then you can determine the discriminant. So you shift the 4 over, you get this, and then your a, which is coefficient of x squared, is 3. Now b is the coefficient of x, is negative 12, and your c is the constant term, or the term independent of x, it is k minus 4. So for equation that have two real distinct roots, discriminant has to be greater than 0. So if you sub in b squared minus 4ac greater than 0, and then you try to solve this. Okay, the reason why two real distinct roots imply x has two solutions, you can have two real and distinct roots, is because this part is discriminant, b squared minus 4ac is greater than 0. If it's greater than 0, you can actually get two values here when you square root it with the plus minus. Okay, if it is smaller than 0, there are no real solutions, which means you do not have any real roots. So after equating into the inequality, you simplify it and you'll get k smaller than 16. So when k is smaller than 16, this equation has two real and distinct roots. Let's take a look at another question. Okay, show that this equation, this quadratic equation, has no real roots for all real values of k. Okay, this time is the show. You have to show. What this means is, first you rearrange it, or you check to make sure it's equals to 0. You identify your a, b, and c. Then in order to show that the equation has no real roots, you need to show that the discriminant is smaller than 0. You need to show. You cannot actually assume from the start that the discriminant equals 0. So what you do first is you find the discriminant. You sub in your b squared minus 4ac. And then you simplify it, you get negative 8k squared minus 12. You need to show that this is smaller than 0. Then you can show that the equation has no real roots. So you cannot state or already assume discriminant smaller than 0. You need to process the discriminant, then show that it is smaller than 0. So how do you show that negative 8k squared minus 12 is smaller than 0? The key thing is this k squared. Since k squared is greater or equal to 0 for all real values of k, then if you multiply by negative 8, this k squared is positive. If you multiply by negative 8, you become smaller or equal to 0. And if negative 8k squared is smaller or equal to 0, if you minus 12, then this whole thing will be smaller than negative 12. And this expression here is actually the discriminant. So what you have shown that is the discriminant is always negative for whatever values of k that you put in. Okay, if you put in k as 10, you sub in, you should get smaller than negative 12. Even if you sub k as negative 5, you should also get a negative value. Discriminant is always negative. Since discriminant is always negative, the equation has no real roots for all real values of k. So this is how you show that the equation has no real roots, by showing that the discriminant is smaller than 0.